Hi everyone, welcome to my project presentation on Superstore dataset using linear regression and the random forest. In this session, I will talk you through the Python notebook, explain the step behind building two predictive models, and share key insight we discover. The aim of this project was to forecast the profit from the Superstore dataset from 2019 to 2022. Using machine learning, we tested two approaches. First, linear regression. Linear regression is a simple and a highly interpreted model, and the second one is a random forest, is a powerful assemble method that captures a complex pattern in data. So, in let's begin by looking at the first code cell. Here we import all the essential libraries for this project. Pandas and NumPy handle the data's loading and the manipulation. Matplot and the Seaborn create a visualization from strict learner. We bring in the models, linear regression and the random forest regression, as well as helper tools like a Gradesheet CV from turning and metrics like MAE, RMSE, and R square. In the next small step, we set a seaborn style to white breed. This may seem minor, but it's make a plots cleaner and easier to read. Okay, so in since this project we run in a Google Colab, so I use file upload function to bring the Superstore data set. After loading, I read the CSV file with the pandas and did a quick check printing the first few rows, checking data set info and the continuous missing values. This helped to ensure the data set loaded and correctly, and let us see what kinds of cleaning might be needed. And then next, we clean the data, and real data set often contain extra information is not useful for modeling. I drop all the columns like order IDs, customer name, and the cities. This do not impact from profit prediction and the cloud culture the model. After cleaning, we convert categories column like categories region and the shipping model into a numeric form using one hot encoding, and machine learning model cannot handle text directly. They needed number to work with. Finally, we split the data set into X features and the target Y. Our features including sales, discount, shipping details, and the product categories with profit in the target we want to predict. To avoid overfitting, we need trust our model on unsensed data. So we use train state splitting. So we use train splitting, divided the data set into 80% training and the 20% testing. The training data teach the model, while the testing data checking how well the model can generalize to new cases. Mm, and now it's time to train our the first model in linear regression. So we train the linear regression model. Linear regression assume a simple straight line relationship between predictors and the profit. interpretable for each features. The model calculate a coefficient that the tell us how much profit change in the future change by the one time. And the second, I trained the model in just two lines from code. This make a linear regression a great starting point if even cannot always capture the full complexity of the data. Then we create a second model, random forest. It's assemble model. It's a build many decision trees and the averages their prediction. This help it handle now linear relationship and the complex inter between the variable. I train is used 100 trees to start. Later you could turn hypermethods like trees depth and the number of trees for even better performance. Random forest usually predict better, but it's harder to explain. We call this is a black box issues. After training both model, I evaluate the performance using mean absolute error, root mean square error, and R2 square. So mean absolute error tell us on the average how far of the prediction area. Mean square error by mistake for the heavily and R square, so how much of the profit variation is explained by the model. The result were a clear linear regression achieved about 72. The linear regression linear regression about 56.89 accuracy, and the random forest where random forest is 95.97 accuracy. Random forest also had a much lower MAE and RMESE, meaning its prediction were far more reliable. One major advantage of a random forest is the feature importance. The model rank with a variable drive profit. The most sales was the top positive drive, while the discount and the strong negative impact, meaning heavy discount reduce profit. Other factors like category segmentation and shipping model also play an important role. Uh, this project show how machine learning can forecast retail profit. In linear regression gave us a simple cleaning baseline random forest and deliver for the better accuracy and the highlight the key drives of profit. This insight can help superstore improve principal discounting and the inventory decisions leading to better profitable. Thank you so much for watching.